Hello everyone, I am Varun Joshi and welcome to Cloud with Varjosh. In this video, you will learn how to build and upgrade a multi-node Kubernetes cluster using kubeadm end to end. We start with cluster creation, cover prerequisites and networking, and then walk through a safe production aligned Kubernetes upgrade, including control plane and worker nodes. This video was originally recorded as part of my CKA certification course, but I am releasing it as a single standalone video so it can reach a wider audience and also be useful even if you are not following the course in a day by day format. One quick clarification. During the lecture, you may hear references like day 7 or day 20. Do not get confused by that. Those are only pointers to how I structured the CKA course internally. This video is complete on its own and you do not need to jump across days. Now, of course, if there are specific topics for which you want to learn more, then of course you can watch that day. But when it comes to creating a Kubernetes cluster and then upgrading that cluster, this video is complete. Please also check the pinned comment where I have added helpful links and notes related to this session. About this channel, Cloud with Varjosh is focused on cloud DevOps and everything in between. You will find structured playlist based content on Kubernetes and CK preparation, Jenkins and CI/CD pipelines, Kubernetes real world projects, Argo CD and GitOps, which is currently ongoing, and a lot more will be coming soon. If you are preparing for CKA or working with Kubernetes in real environments, I recommend picking any one topic you are unsure about from the playlist and watching just that lesson. You can either treat the channel as a topic library or follow a series end to end. If this kind of hands on production aligned content helps you, do like the video, say a quick hello in the comments, and consider subscribing. With that said, let's get started. Today, we will build a multi-node Kubernetes cluster from scratch using kubeadm. We will install containerd as the container runtime or CRI plugin and Calico as our CNI plugin. The installation of Calico will be done in the recommended approach, which is we will be using Calico operator to install the Calico CNI plugin. We will do this on cloud VMs. We will be leveraging AWS's EC2 instances to create our multi-node Kubernetes cluster. But be assured that you can perform this demo in any virtual machine. So be it in your home lab, on premises, any cloud provider, or your laptop's hypervisor. Just ensure that the ports and protocols that we are allowing in our security groups, you also allow those in your firewall. In case you are using any other operating system than what we are using for the underlying nodes, then you would also have to do some tuning and tweaking, but at a very high level the steps that you perform will be pretty much similar, if not same. But be assured that since I'm using Ubuntu, you also use that if you want to follow the steps that I will use in this demo. With that said, let's go to the browser and see what are the prerequisites for this lecture. We are on day 54 and here are the prerequisites. The first one is you should understand the Kubernetes architecture. I do not have to answer why, because we in today's lecture will be configuring all these components, will be installing all these components. So it is of paramount importance that you understand what these components do, how the control plane and data plane components come in action to give you a fully functional Kubernetes cluster. So watch day 7 to have that understanding. And we also followed the deployment workflow in this lecture. And this is a favorite question for interviewers. Explain what each component is doing in detail, step by step, inch by inch, bit by bit. So if you can answer that, that's awesome. Then we have day 25. In day 25, we discussed how the Kubernetes architecture is modular. It's not that everything that is Kubernetes is done by the Kubernetes community. There is a core part in Kubernetes that is container orchestration, which is managed by the Kubernetes community. And then there are rest of the things. There are add-ons, there are plugins which are externalized. To understand how this modular architecture works and is beneficial and what exactly it is, I would recommend you that you watch day 25. I also have a 5-minute checklist. So if you understand these terms and how they fit in to ensure that your workloads are run properly, you are good to proceed with this lecture. With that said, let's get started and see what we are going to do. Build a multi-node Kubernetes cluster with kubeadm. We will be deploying version 1.32 of Kubernetes, 1 being the major version, 3.2 being the minor version, and .8 is the patch release, which we will see as we progress with this demo. We will be deploying 1 control plane node and 2 data plane nodes. So let's go to the diagram and understand what are we going to deploy. I scroll down. So here you see a control plane node and you see 2 worker nodes. Both of these worker nodes form the data plane. In case you have more worker nodes, they will also sit in the data plane itself. We have yours truly sitting here, Varun. Varun is the user who will be configuring the cluster, and once the cluster is configured properly, Varun will be verifying that indeed whatever is deployed as an application is accessible. And we know for local testing and development, we use the node port service. Hence, what I have done is in my control plane nodes and in my data plane nodes, we have allowed inbound on port 22. Inbound implies incoming connections. If you have any confusions pertaining to inbound, outbound, how all these things fit into the bigger picture of networking, I would suggest you watch the network policies lecture, which is in the description box. Now, 2 ports we know inbound must be allowed. One is SSH, that should be allowed in both the control plane node and also the data plane node. That's one. Second is in the data plane node, we also must allow the node port range. Now, in case you are using a specific node port, in that scenario, you will only allow that node port. But in my scenario, I will leave it to allow every node port, and then I will be deploying my application, and that application will receive a random node port, and that node port will already be allowed. Then I want to explore the communication between the control plane nodes and the data plane nodes, and also the communication between the worker nodes themselves. So let's see what we are allowing. Firstly, as we will be using Calico as our CNI plugin, we must allow the Calico ports. Calico uses port UDP 4789 when you are using the VXLAN mode. Here we are saying UDP 4789 is allowed bidirectional. So worker node 1 can access worker node 2 on this port, and vice versa is also true. That is, worker node 2 can access worker node 1 on UDP port 4789. 4789. Now this 4789 is also allowed bidirectional between the control plane node and the data plane node. Now if you are wondering from where did I get this information, I got this from the official documentation. So if I go to my browser and I go to this tab, system requirements Calico, you will see that 4789 bidirectional is required when VXLAN is enabled. So we will be using VXLAN. In case you use IP in IP, then you would need protocol number 4. In addition to that, if you are using BGP routing, you might also want to include TCP port 179 in the communication. And here it is mentioning which hosts should have this allowed. Since it is all, we know that when we are allowing UDP 4789, it must be allowed everywhere in our cluster. Hence, we have done this. Then you have ports and protocols. This is from the official Kubernetes documentation. And from here, I have picked the port I need for my implementation of Kubernetes cluster. The key word here is my implementation of Kubernetes cluster. If your use case is different, then you will have additional ports as well. And we will see when you will have additional ports. So let's go back to our diagram here. And what we see is Calico, as we have discussed. Then we are also saying our worker nodes are allowed to speak with the control plane node on port 6443, which is why we will be allowing inbound in control plane node on port 6443. Why is this needed? When your worker nodes will join the Kubernetes cluster, they will be accessing the control plane on port 6443. That's why we have this. And at the very last, you see control plane is allowed to communicate with our data plane on port 10250. Hence, our data plane must allow inbound on port 10250. Now someone is wondering, I know, why would the control plane want to speak with the data plane? So why would the control plane speak to kubelet? Or in other specific words, why would the API server want to speak with the kubelet running in all the worker nodes? The answer for that is whenever you run kubectl logs or kubectl exec, your API server communicates with the kubelet on port 10250. Hence, this port must be allowed in all your worker nodes inbound. Now, this is what we will be doing in case you have these scattered. So what we are doing is all our control plane components are in the same virtual machine. Hence, we do not have to allow anything to speak with each other. So for example, we know that API server communicates with etcd. Since this is the local host, all of these components are in the same virtual machine, I do not have to specifically allow any communication between the API server and the etcd node. In case I would have deployed etcd outside, as a separate virtual machine, then I would have to allow additional ports. I will have to allow etcd in the etcd firewall. I will have to allow inbound on a specific port. So if I go to the documentation again, then you see here 2379 and 2380 are the ports which are used between the API server and the etcd communication. And another thing I want to bring to your notice is API server is the central point for all communication. Any component that wants to speak to another component, the communication goes via the API server. So keep that important distinction in mind. Now that we have the understanding of our architecture of what we are going to deploy, let's go to the AWS console and see how I have configured my security groups. So let's go to the browser, and here I have my security groups. I'll hit a refresh just so that you have the latest information at your disposal. You see there are two security groups created here. There is a control plane security group, and then there is a data plane security group. I want you to clearly understand that I have not created different security groups for my worker nodes. I have two worker nodes. I have not created two security groups for them because I want you to clearly understand that worker nodes come and go. If worker node 2 dies and worker node 3 comes up, there is no security group for worker 3. That is not something you want. Hence, what I have done is I have created a common security group. That security group will be associated with the ENI of any worker node that gets created for this implementation. So I have two worker nodes. Both of my worker nodes will be using this security group, and I only have one control plane node, and hence I have one security group. Even if I had multiple control plane nodes for high availability, I would still associate all of them with a single control plane security group. Now that we have that understanding, let's study the ports that we have allowed. So if I go to the control plane security group first, I will scroll to the right, and you see there are only three rules, 6443, and that's the beauty. Now I have the source that is allowed to communicate with my API server with my control plane node on port 6443 is my data plane security group. So anything, any ENI, any worker node that is associated with this security group is allowed to speak with my API server. Why with my API server? Because control plane SG is the security group that I will associate with my control plane node. In the second tab, I'm saying the same thing, but I'm saying this is for UDP port 4789, and 4789 will be used by Calico. Lastly, I am allowing inbound on port 22 from this specific IP address. Whose IP address is this? This is the IP address of yours truly. Now let's see what we have configured for the data plane security group. I'll go here, and here I have 5 rules. First two rules are self-explanatory. One is for SSH that yours truly will be using to SSH into the data plane nodes, and this rule is to test the application that we will deploy once the cluster is up and running. Then we have 4789. First 4789 allows the communication from the control plane node. Second allows the communication from the data plane SG. But Varun, we are watching the rules of data plane SG. I want you to create a mental picture in your head. If I go back to my diagrams, you have worker 1, you have worker 2. They both are associated with data plane security group. What I am saying is when worker node 1 initiates a communication towards UDP port 4789 on this worker node 2, then this worker node 2's SG must allow that communication. And what is the security group that is associated with worker node 1? Worker node 1 has security group data plane SG. What is the security group associated with worker 2? It is the same security group. Hence, I am allowing communication on port 4789 UDP for data plane SG. This is a self rule. Last one is 10250, and this is from source control plane SG, and this is for kubelet communication as we discussed in the diagrams. Now that we have this understanding, let's go to the EC2 tab and create instances for us. I want you to know that I am logged in as varun.joshi. It's an IAM user, and then I am logged in into an account whose alias is cloud with varjosh-prod. Now what I will do is I'll click on launch instance. I will call this instance control plane as expected. Then I will choose Ubuntu. I would recommend you also choose Ubuntu if you want to follow step by step what I am doing. Then here I will keep everything at default. Then I will go to instance type. Now I will be choosing T3 medium for my control plane node, and I will recommend you do the same because kubeadm asks you to have two vCPUs in your control plane node. Now there is a way to bypass that flag. So when you are configuring your machine to be the control plane node using kubeadm, it will give you an error stating that your machine does not have two vCPUs in case you spin up a machine with one vCPU. There is a way to bypass that, but I want to follow the recommendations in this demonstration. Hence I am choosing T3.medium. So I'll click on it, and if you go to the GitHub repository, I have jotted down the flag that you can use if you receive an error and you are using one vCPU. And now is the interesting part, key pair. Now I have already created a key pair here, and I wanted to spend some time on this tab. Now you know that nomenclature is of high importance to me here as well. Here is the account that I am dealing with, as in the project I am dealing with called Cloud with Varjosh. Then is the environment, which is prod, as you can see here in this account is for production. And then I have the region name, and then I have the last four digits of my account number, AWS account number. Now why I have named it like this, because if I watch this in this AWS console, I can figure out all these things, which region, which account number. But I want you to know, if I go to my terminal, you will have all these .pem files downloaded, and if you have multiple of these in your machine, you should be able to identify to which project this key belongs. Hence naming it properly is important. Now if you do not have this key pair already generated, then what you can do is you can click on here and generate ed25519 key pair. And then I will cancel this. I would suggest you that you also use your provider's mechanism to generate this key pair. In case you want to self-generate it using SSH keygen, then ensure that you also copy your public key in the authorized key file. And steps for that are also available in the GitHub repository. Now I will scroll down here. I want to choose the security group. The security group that I will choose is the control plane SG, because I am creating control plane node. I'll click here, I'll scroll down, and now I'll click on launch instance. Instance is launched. I'll come here. It is still initializing. And if I go to volumes, this is the volume that was recently created. 1237. It is 1237 on my clock. 8 GB. I have chosen this to be 8 GB, which is the default. If you want more, you can configure it accordingly. So I'll go back to instances. I'll click on this. I'll click on connect. And from here, I will copy this. And then my .pem file is located in the download. So if I click ls, you see it is here. I will put this command here, and then I will press enter. So if you are not in the directory where your file resides, .pem resides, then you will have to provide that path here. Another thing is you will have to give 400 or 600 permissions in your .pem file. So in case you don't have those, you can do this using chmod and then 400, and then you can provide the name of that file, press enter, and if you hit ls-la, then you see here is your permissions. So the owner only has read permissions. If you want to be a little more lenient, then you can provide read plus write using 600. Let me copy that command again from here. I'll copy it, I'll paste it here, I'll press enter, and I should be inside the virtual machine. It is asking me, are you sure you want to continue connecting? And if you have seen my SSH lecture, you know that we are doing tofu. Tofu is trust on first use. So we are trusting the fingerprint. There are other mechanisms which we discussed in our SSH lecture. If you want to know more about it, you can watch that. I'll press enter and it is adding this into our known hosts. Now we are logged in. I'll clear my screen. The first step I want to do is I want to give this machine a proper name so that as soon as I see it, I know this is my control plane node. So I will go here and I'll scroll down, further down, and here is the command I want to run. I'll run it and I will run exec bash. It's just a refresher for my terminal, and you see the name is here. Now let's go to our GitHub repository and see what we want to do. Now I have clearly called out what steps are to be performed in which nodes. So be extremely careful when you are applying these. For example, I have written disable swap and set kernel networking. This is supposed to be performed in all your nodes. So be it worker or be it control. Let's run these commands. So what we are doing is we are disabling swap and we are preparing the kernel for Kubernetes installation. We are modifying certain parameters to ensure that our VM accepts the installation that we want to perform. So I will copy this and then I will go to my terminal. I will paste it here. I'll press enter and this is done. Now let's move to step 2. Step 2 is install and configure containerd. Containerd is our CRI plugin which we will use as our container runtime. So in the first step, we are installing containerd. In the second step, we are aligning containerd with kubelet's expectations. I want you to clearly know that when kubelet receives or asks API server about the specifications of the pods that must be configured, it communicates that information to the container runtime so that container runtime can pull the image that is needed and work with CNI to configure the networking. Hence, it is important that containerd is configured in such a way that kubelet can seamlessly communicate with it. That's what we are doing in this step. Then we are performing few reload operations. Another thing that you can note from this is we are installing containerd as a unit file, as a service. So now we will copy this and we'll go to our terminal and we'll paste it here. And this should show running and active to us. Perfect. This is active and running. I'll hit Q and then let's go here and let's see what we want to do in step 3. Step 3 again, all nodes. This is the point where all the action is happening. We will be installing kubeadm, then we'll be installing kubelet and kubectl. So let's copy this command and I will paste it here. And as you can see, everything that we are installing is of version 1.32. And then the patch release version is 0.8, which we will see soon. Let's go there and you see it is 1.32.8, the kubeadm. Kubernetes is 1.32.8. Client version, that is our kubectl client, is 1.32.8 as well. Now it is the recommendation that your major minor versions between the Kubernetes version and kubectl version should be ±1. Then here is the customized version. We know that customize is built in the kubectl binary. Hence you also see customized version when you run kubectl version command. Let's go back to our browser and see what we want to do next. Bash completion, optional but helpful, and I always want this, so I will run these commands. I'm not someone who prefers this alias. If you like it, like we have been writing kubectl get pods, if you want to write just k get pods, you can also install this alias. Now it is not what I prefer. You will be writing the CKA exam. If this saves you time, and it does, then go ahead and use k as an alias. I did it in my environment, but I have a habit of typing kubectl, so I could never get a hang of it. So let's go back here. It says it is done. Now let's see what we want to do next. Step 4 is the command that will tell this virtual machine that, my friend, you are the control plane, so take the responsibility. So let's copy this command. I'll go to Visual Studio Code. I will paste this here, and I want you to understand this. First is, we are saying this is the control plane endpoint. As we know, we have opened port 6443. It is the port on which our API server will be listening on. Then we are saying the advertise address for API server is this one. We will copy the IP address soon from our AWS console. This is the point I want to concentrate on. Understand that there is a separate subnet that we are saying this is the pod network CIDR. I will leave this here right now, and we'll discuss more about this later. But I want you to remember this, that we have added a pod network CIDR, which is 192.168.0.0/16. So I'll go to the AWS console, and then from there what I will do is I'll copy the private address of this node, and I'll go to Visual Studio Code again. I will paste that IP here and here, and then I will copy this, and then I will paste this onto my terminal. I'll paste it here, and it will take 30 seconds or even less. Let's allow it some time. It has installed successfully. Now this node is initialized as the control plane node. So what I'll do is, it is saying to start using your cluster, you need to run the following as a regular user. What are we doing in this step is, we are creating our kube configuration file. Now if you have any confusions about kube configuration file, then you can watch the attached lecture. But the important thing is, whenever you are connecting with your API server, it is the kube configuration file that is used by your kubectl client to perform authentication. It is used to authenticate the API server as well, and it also holds the certificate which you present to the API server to confirm your identity. Even if we are in the control plane node, we will still have kube configuration file when we want to use kubectl client to connect or send commands to our Kubernetes cluster, because that is basics of authentication, which we have discussed in greater detail in our TLS section of this course. So for now, I will just copy this and I will paste this here. I'll press enter, and this is done. I can now run kubectl get nodes, and it will not show me the nodes. Let's allow it some more time. Let's run kubectl get pods. If this doesn't run, then we should allow it some more time. 43,189, 43,189. Let's go to the console. It's 43,189. Now let's run again kubectl get pods. Show me something, man. Let's do some basic troubleshooting. Let's run kubectl get pods once again, and then we'll do something. Let's run kubectl. Let's run sudo systemctl, and then I want to see status of first kubelet. Kubelet is running. Error syncing pod, failed to get status, and these messages were a while back. Okay, this looks okay to me, but right now the service is running just fine.
Then let's check the status of container D, and that should not matter because we are not able to connect with the API server right now. The error is different. kubectl get pods. Let me check if any step is pending. I'll go to my browser. I'll go to this. We have run this. No, CNI we have not installed. We don't want to install that right now. Here it said initialized successfully, and then kubectl get pods. If this doesn't work, I'll take a reboot of this server. Sudo init 6. See, in my practice sessions preceding to this lecture, there was never a successful installation. Never. I had a different error all the time. And if you visit the GitHub repository, you will see what all things I did to get rid of those errors. Mostly it was I reconfigured something, because see, I want you to know that there are hundreds of services involved in order to ensure that everything works as expected. Now, at times there is a possibility that something gets hung here and there. In that scenario, a reboot will help, or reconfiguring that service will help. At this stage, when you are creating a development cluster, then it does not make sense to spend all your energy in troubleshooting. You have to choose your battles wisely. In case you face problem with your production cluster, then of course you work, troubleshoot and fix the problem. But when you are dealing with development workloads, to save on time, the first thing is you try a reboot. Then the second thing is you try to reinstall that service or component. And I have jotted down the steps in the GitHub repository on how to do both of these. So for now, let's see if this reboot helped us or not. In case it didn't, we'll have to do something else. Now let's run kubectl get pods, and you see a reboot reinitialized everything, and it is working as expected now. So let's run kubectl get pods. No pods in the default namespace. kubectl get nodes. There is one node. The status is not ready. kubectl get pods -a. Pods are running, but they have restarted a few times, which is fine. The cluster is recently created. Control plane node is recently created, but I want you to observe a few things right away. First is the core DNS pods are in pending state, which implies the scheduler, which is in running state, has not even scheduled the core DNS pods. First point is this. Now these pods are running and all of these are in healthy state. Why do I know these are in healthy state? Because the status here is 1 on 1. All of these pods, they only have one container, and that one container is up and running. So let's run this command again, and you see it is still fine and the number of restarts has not changed. Now I want to run one more command. I will run kubectl get pods -a-o void. Now why I am running this is, firstly, I want to show you that all of the control plane components along with the kube proxy which is running as daemon set, has the IP address of the node itself, of the control plane node itself. So if I go to my AWS console, you see that our node has 43.189 and this is 43.189. Again, we have received the IP address from the VPC CIDR, which is obvious, but any workload pods that we create will have IP address from this subnet, and we will see that as we progress with this lecture. Now at this stage itself, what I want to do is kubectl create deploy. I will call this a web, and I will say that I want this to use image of Nginx, and then the replicas that I want are 2. I'll press enter and this will create a deployment. And if I run this command kubectl get pods -a, then I see there are 2 web pods created as we asked, and these pods are in pending state. So now I want you to note that the core DNS and the web pods are in pending state. Rest everything, our control plane is up and running. If I run kubectl get nodes here, I still see the status is not ready. As soon as I configure the CNI, this status should ideally change. So let's go back to our browser. I will come here and then I will install the CNI. So what we are doing is we are using operator for this installation, and what we are doing is we are saying that here the CIDR for the pod networking is 192.168.0.0. If I had mentioned something else here, then this would have errored out, because what we have defined in our command is this CIDR. Hence this CIDR should match what we are defining here. Now if you are not sure, because this one is also the default for Calico will choose this CIDR for your pod network, but if you are not sure about the defaults, then you do not have to mention this. But if you do mention this, then whatever the pod CIDR is for your CNI, for Calico the default is this, but for Flannel or if you're using any other CNI, you will have to check the default for that and then run it, because these two should match. Or if you are not sure, do not put this at all. Now I will copy this and I'll go to the terminal and I'll paste it here. I'll press enter and this will install a lot of things. And now I can run the same command again, kubectl get pods -a. Now when I run this, you see there are a lot of pods created. Here is the Tigera operator, and then you have Calico node, Calico Taifa, Calico cube controller, and so on. Now I want to clarify a few things right away. This is something that you need because this and the controller, they both are required here. But Calico node, let me also run kubectl get ds -a. I have run kubectl get daemon set. I will also run kubectl get deploy -a so that you know what is deployed as what. I want to call out right away, Tigera operator is something that we will use. Calico Taifa we do not need, but this comes with the installation. Then you have cube controller, Calico cube controller. This is something that we need. Then if I talk about daemon set, CSI node driver is something that we do not need. Now I want to mention a few more things. What I have done is I have specially instructed this command that we have run here to not install anything extra. So we have used this command, but if you go to the documentation, you will be installing a lot of things. So if I copy this, what I have done is I have only installed a section from this. So if you see the default one, I will quickly paste it here. And if I cat this file custom resources, then you see it was installing these things as well by default, but I have not installed any of these. We have just installed this part. Now if your installation warrants these things, then be my guest, but your installation should be minimal. We still have Calico Taifa and CSI node driver. We don't need these things. Now based on discussions with Tigera, you can ask them how to remove them. You can either directly remove this deployment and daemon set, or you can ask them to give you an installation bundle or installation manual that will not include these. Now I could have done this in such a way that these were not installed, but that would have made things a lot more complex. Hence I will leave this to default, but I want you to concentrate on one thing. Kubectl get pods -a. Now you see there are two pods that are in pending state, and these are our web pods. But the core DNS pod are in running state, and they came in the running state as soon as we configured the CNI. And why is that? So to answer that question, let me run kubectl get pods -a-o wide. Here you also see the IP addresses of these pods. You see the core DNS pods, they have an IP address 192.168.235.132. I want you to clearly understand this IP is from the pod cider. So core DNS pods were awaiting the CNI to come and allocate the IP addresses to this pod. I want you to again understand that it is the kubelet that tells the CNI, configure the networking for this pod, give me the IP address, assign the IP address, and it is CNI's job to do IPAM and to only allocate IPs that are unique and available. Hence, core DNS only received the IP address once the CNI was configured. So this is understood, Varun. But why are my web pods still in pending state? Because now we have means via which they can be assigned IP addresses. But why are still they in pending state? They are in pending state for a different reason. You know that the control plane node has a taint which prohibits pods to run onto the control plane node until and unless they have a toleration for it. Now the control plane node has a taint for which our web pods do not have toleration, whereas the core DNS pods did have toleration for the taint that is there in the control plane node, which is the reason our web pods are still in pending state. Now what we want to do is we want to create worker nodes so that our web pods can be scheduled and our website can be accessed. So let's go to the AWS console. I'll click on launch instances. I will do this a little quickly because we have already done this for our control plane node. I will change the number of instances to 2. We'll rename this one later. I'll use Ubuntu image, and then here I will choose t3.small, and then I will in the key pair choose the one that we have used before, and here I will select existing security group, and this time I will choose the data plane security group. I'll leave this to default. I'll click on launch instance. By the time this instance launches, let's prepare our terminal. I'll go here. I will press Ctrl T to have a new tab. I will zoom in here, and then here session. In the shell part, I will split vertically with current profile. Now what I am doing is this tab will be for my control plane, and second tab that I have opened will be for my worker nodes. This will be for my worker node 1, and this will be for my worker node 2. I will cd into downloads in both of these tabs, cd downloads, and then let's go back to our browser. And from here we can check out how do we connect to these instances. So worker 1 is this I will rename to worker 2. For the first instance, let's click on connect, and this will tell us the command that we can use. Here I can paste it, press enter. Now let's do it for worker 2 as well. I'll go here, select worker 2, and then I will click on connect. I will copy this, and then in the second tab I will paste it, and here I will give yes, trust on first use. Here as well I'll give yes, trust on first use. Then I will give it a host name. So what I will do is I'll go to my repository, I'll scroll at the top, and here somewhere in point 4 I believe I have the command that you can use to set the host name. So I'll paste it here, and then I will call this one worker 1, and here also I will paste this, and I will call this worker 2. I'll press enter, and now what I will do is I'll do a setting which will allow me to run commands in both of these terminals simultaneously, because we are running the same set of commands in both of these worker nodes. So I'll go at the very top here, and then I will choose shell broadcast input to all panes in current tab. I'll okay this, and then I will write exec bash, and then I will clear my screen. You see worker 1 and worker 2. Now let's go to our repository and copy the steps. So we'll disable the swap and set kernel networking first. I'll paste it here, and then this will run in both of our nodes. Then we'll install and configure container D based on the expectations of kubelet. We'll paste it here. This will continue to run. Then again, kubeadm, kubelet, kubectl, we can install in all the nodes. You may choose to not install kubectl in worker nodes, but I am installing it because we might face problems which will warrant us to use kubectl. Hence, I am installing it. But there are scenarios when you will see worker nodes do not have kubectl client. So I'll copy this, and then this is done. I will press Q, I will paste it here, and then this will install kubeadm, kubelet, and kubectl. I'll scroll down, optional but helpful. We want helpful, hence we will also have command completion in place. So let's install that as well. You see all the versions are installed like we instructed. This is good. This command was supposed to be run only in the control plane. We'll skip this. Step 5, install Calico CNI via operator. This was also meant to be run only in control plane node. We'll come down. Here is the command that we will use to join the worker to the control plane node. So workers are with us right now, but those workers do not know who is their brain, who is their control plane. So we'll copy this command. This will give us the token that the worker nodes can use to join the control plane node. I'll click here to the control plane node. I'll paste it here. I think the SSH connection is lost. Let me quickly restart this session. Restart session. Okay. And yeah, I'll cd into downloads, and then I will log in. Let me just copy that command again. Here I am in the control plane node. I'll paste it here, and this will tell me the command that I can use in my worker nodes for them to join this control plane. I'll go here now, and then I can run these commands here. And this says error is privileged user. I will have to add a sudo before it. Sudo, and I'll press enter, and this is working. So now let's go to the control plane node. I will run kubectl get nodes. I see worker 1 and worker 2. Their status is not ready. So understand that Calico components, they are running as daemon set. So the pods that are required by that daemon set may still be in not ready state right now. They might still be in container creating state. So let's see kubectl get pods -a, and now all the pods are in running state. So if I run kubectl get nodes, I see a ready status in both of the worker nodes that we just added. And another thing that I want you to note is our web pods are now in running state. Now, why are they in running state? Now they are in running state because now scheduler can schedule them onto a node that does not have a taint, and our web pods also do not have any tolerations defined. Hence, scheduler scheduled both of these pods onto these nodes. Now let's run kubectl get pods -o wide. Both of these are scheduled in worker 2. So let's go to our browser again. So we have just created a deployment. Now we will create a service that can be used to expose this deployment. So we'll be exposing this with a node port service. I'll paste it here, and if I run kubectl get svc, I will know the node port which is assigned to this node port service. It is 30621. So I will go to my browser now. I will go to my instances. I only want running instances. And then here I will choose worker one, let's say first. I will copy the public address. This must be HTTP. Okay, just remember this because we do not have any TLS certificates yet. I will paste this here, IP, and then what was the port? Port was 30621, 30621. I'll press enter and this is still working. Till that time, let's go to instances. I will go to worker 2. I will copy the public address of worker 2, HTTP forwards, it is HTTP forward slash, and it was 304 30621, 30621. I'll paste it here. I'll press enter and this works. This one is still processing. So which one worked for us? It is worker 2 that is working. It is on worker 2. The pods were scheduled on worker 2, but they should be accessible from worker 1 as well. There is something wrong with worker 1, I believe. Let me copy the IP address again. I'll go here, paste this here, and the node port was 30621, 30621. I'll press enter, or maybe this is HTTP and then forward slash. Why it is not working on worker 1? So let's do one thing. Let me take a rolling restart so of this deployment. So kubectl rollout restart deployment, and the name of the deployment is web. I'll press enter. So this has restarted. If I check this kubectl get pods -o wide, I see completed. Why will an nginx pod complete? Okay, it has taken one restart. Worker 1, worker 2. Now let's see if it works or not. Oh, it works now. I think rolling restart was the deal that made it work. I will clear my screen. Let's run kubectl get pods now. This pod has been restarted once and this pod was on. This should not have been restarted. Why is this restarted? Let's do one thing. kubectl, let me do one thing. Let me create some more pods. kubectl scale deployment, and the name of the deployment is web. I want this to have, let's say, 10 replicas. Okay, what I don't want to see is I don't want to see these restarts. Why did it restart it? kubectl get pods. Okay, all are in running state, and I'll add -o wide here as well, so that, okay, most of them are scheduled in worker 1. What's wrong with worker 2? kubectl get nodes. Worker 2 is also ready. Let's scale this further. kubectl get pods -o wide. Okay, now it has distributed the load amongst worker 1 and worker 2, and the pod that was on worker 2 has undergone another restart. This is strange. This pod should not be restarting. This implies there is something not right with worker 2. Let's see what is happening here. Because let's do one thing. kubectl, I will quickly check the logs for this pod. kubectl, first let's check logs and then we'll see the describe for this. Logs, and this is web and JZ. Oh, nice name. And if I press enter, it says OS this start worker configuration. This does not give me anything substantial. So let's do one thing. I want to run a describe on this pod too, because it has restarted 2 times, which is not fair. kubectl describe pods, and this is the name of the pod. Pod sandbox changed. It will be killed and recreated. Now sandbox changed. This error pertains to either your kubelet malfunctioning or container D malfunctioning. I'm not sure which one this is. So let's run that again. And if we again see problems with any of the pods, then we'll have to troubleshoot further. Okay, now worker 2 is also facing this, and now worker 1 is also facing this. If I go to the browser, this thing is working, but my pods are getting restarted. Mm-mm-mm. Let's give it some more time. Let's see if other pods will also experience this, because if one is facing, then others will also face this. Yeah, there is one more in worker 1 now. So our pods are automatically restarting. And let's run a kubectl describe pods on this one as well. Pod sandbox changed. It will be killed and recreated. Let's run this get pods again. Now I checked the logs of kubelet and containerd. They both appeared to be functioning okay. And then what I also did is I ran these commands. So what we are using is we are using containerd as our container runtime. So if we were using Docker, we write Docker PS to see what are the containers that are running when Docker was used as the container runtime. But in here, we are using containerd as the container runtime because Docker has been deprecated since version 1.24. Now, with Docker, we used to run Docker PS containerd, so falls under the CNCF umbrella. So what we can do is for that, we can run CRICTL PS, which will show us the containers that are running in a worker node. So if I press enter, this will show me all the containers. Now I'll have to also add a sudo. I'll add sudo, and if I run, it will show me all the containers that are running in my worker node. Now I want you to understand a few things. Here you see the attempts to restart have been 0, but when I see control plane nodes, you see that there have been restarts in the control plane nodes pods. Why is it? Because if you look at here, when I rebooted the control plane, the existing pods that were running in the control plane, their restart counter increased, and when I configured the control plane, they automatically had few restarts while the control plane was being prepared. But when I talk about this web deployment, what I did was I deleted the web deployment. I took a restart of all my nodes, control plane node and the worker node, and then I redeployed this, and then I observed it. So if you see, I have been observing it for, if I run, I'll again, this session is lost. If I restart this session, hold on, cd downloads, and if I run the sh command again, if I run kubectl get pods now, you see that all these pods have been running for 20 minutes without any problem. So the crux of my findings is when you create a new cluster, you allow it some time to stabilize. But once you have run all these commands, you should give a restart to your nodes. And this applies for both your control plane and your data plane nodes. Once the restart is performed, only then run the workloads. And before that, also observe whether the pods are restarting or not, whether all the pods are accessible over all the nodes or not, if you are using a node port service. Now let's test what we want to finally test. So I'll run kubectl. Let me go to the browser, and in here what I will do is I will create a node port service. I'll copy this command, I'll come here, I will paste this command here, and then it says already exists, so it exists. So let me run kubectl get svc, because I didn't delete the service, I just deleted the deployment, and you see 30621. If I go here, 30621 was the same. If I hit refresh, I hit refresh here, let me check the IP. Oh, it is working. Like you see, this also works and this also work. So there is no fun in creating a cluster in one go. I have practiced at least 3-4 times before recording this session, and each time I was hit with a different error. So which is why what I have done is, if you go to my repository, I have listed down few of the troubleshooting steps. Now if you are stuck somewhere, if you want a clean slate, do not just recreate your servers. You can always run these commands in your respective nodes. For example, if control plane is facing some problem, you can run it. This will clear all the installation that you have done, and then you can refollow the steps. But again, the crux is, once you have done everything and it looks like everything is working as expected, I would still suggest you to perform a reboot. And I have checked various sources before making this statement. Perform a reboot and allow cluster some time to stabilize. In today's lecture, we will be upgrading Kubernetes using kubeadm step by step. Before we touch the cluster, we will cover versioning and release cadence, support window and real world practices, skipping versions and sequencing, version skew, which is component compatibility. Then finally, we will move to the upgrade section. We will upgrade a multi-node Kubernetes cluster with kubeadm control plane first, then workers, one at a time, using Cordon, drain, and verifying everything works as expected. We aim for minimal disruption, but we do not promise zero downtime upgrades, especially for stateful apps. And we will look into why I am making this statement. We will do this demo on cloud VMs provisioned in AWS cloud, but the exact same steps work on any VMs, be it in your home lab, on premises, or any other cloud provider. Just ensure the image, the operating system that you are using matches mine, which we deeply discussed in the previous lecture, that is day 54, where we created a multi-node cluster running version 1.32, and today we will be upgrading that cluster to 1.33, which is the latest release by the Kubernetes community. With that understanding, let's get started with this lecture. In this lecture, to cover the theory part, I will be using GitHub notes because there are few nuances that I want you to be aware of before we start with the actual demonstration. So let's go to the GitHub notes of day 55, and here I am, and these are the theory topics that I want to cover. In the introduction section, I want you to concentrate on this step where I am referring you to day 54. In day 54, we created a Kubernetes cluster. If you do not have a Kubernetes cluster, then what will you upgrade? Keeping that in mind, ensure you have a working cluster with you before you start with this lecture. And please do that, because I want you to run the commands with me step by step so that you have a real-time experience. Do not just watch the video and think that I'll do it later. This demonstration can act as your runbook when you are actually doing production upgrades. So stay with me and do the demo along with me. First is versioning and release cadence. Nomenclature: major.minor.patch. So whenever we are talking about Kubernetes version, we say we are running 1.32.8, and this is the version that we installed in our previous lecture. So 1 here is the major part, 3.2 is the minor part, and patch is the patch release. Patch releases are typically to introduce some bug fixes or security fixes. Minor releases introduce new features, and 1 is the major release, which has been constant since the inception of Kubernetes. So 1 has not changed. What you will see change is the minor version and the patch release. The frequency of minor releases is typically every 4 months. So you will have 3 releases approximately per year. Patches are released typically on monthly basis. Now, why this matters? Plan an upgrade window roughly once per minor and expect early patch drops soon after you move to a new minor version. I want you to know, when you are dealing with production environments, you will not be running the latest version at all times. You would typically be working with n-1 or n-2. But you must keep in mind that Kubernetes, the upstream Kubernetes, only support 3 versions. So if right now we are on 1.33, then the Kubernetes community will only support 1.33, 1.32 and 1.31. So as soon as 1.33 was released, 1.30 was deprecated, as in it was not supported by upstream Kubernetes. Implication: if current is 1.33, only 1.33, 1.32, 1.31 receive security bug fixes. Plan upgrades accordingly, which is why I am saying, when you are dealing with production environments, you will typically be using n-1 or n-2, because if you are running a version that is not supported, then you won't be receiving security updates or bug fixes. And this is critical in production implementations. Your security teams, your DevSecOps teams are concerned about what versions you are using, whether they are in line with industry best practices or not. But here is a caveat. Cloud providers are typically liberal in this scenario, and they charge you a fees for being liberal. So for example, if I talk about Amazon EKS, you have an extended support. So I will let you check the documentation for the respective cloud provider so that you can see what is the support matrix for your respective cloud provider. I have attached all the links in the references section of this repository, so do check it out. Now let's see some production insights. I want you to take this with a pinch of salt, because this is subjective. This is subjective to the project you are dealing with. Maybe you have to ensure that you are always running n-1. In that scenario, you will be upgrading your cluster every 3 to 4 months. I'm talking about the minor release right now. In some scenarios, you would be upgrading every other minor release. So if you are on 1.31, you might not be upgrading to 1.32, but you will be upgrading to 1.33. Again, this is subjective, but even if you are running 1.31, you will still be updating your patch release. Patches must be the latest. You must be running the latest security patches in order to ensure you match the upstream Kubernetes. That's one. Second, to keep your security teams happy. Here is an important point. Prod rarely jumps to brand new N, which N implies the latest version. Even if you are on N, it is usually not the day 0 latest patch. You will wait for follow-up. For example, right now 1.33.4 is the latest version. You will not see production grade implementations using that version, because it is the latest version first, because it is the latest minor release, but it also has the latest patches. So in production, you will not see such scenarios. But again, if you spot N with the very latest patch in production, then do let me know, because I am yet to see a production implementation which is running the latest minor release along with the latest patch. But in today's demo, we will be going to the latest minor release along with the latest patch. Now, this is an important point. Skipping versions and sequencing. So if you are on 1.31 and you want to go to 1.33, then you cannot directly do that upgrade. It is a sequential upgrade. You first go to the next minor release, then you go to 1.33. Even if you try to do that, that path is not directly supported. Hence, it matters that you are doing the upgrade step by step. Next point is order matters. You first upgrade the control plane and then workers. Within each tier, upgrade one node at a time for production. So in our scenario, we have a control plane node and we have two worker nodes. We'll first upgrade the control plane, then we will upgrade worker 1, and once worker 1 is working all right, only then we move to worker 2. Then here is the version skew. I want you to know one thing. See, we are using kubeadm for our upgrades and we will choose to upgrade all the components simultaneously. So all the control plane components along with kubedns and kubeproxy. However, there could be certain scenarios, certain corner cases where you might want to only upgrade certain components at once. In that scenario, you must ensure a safe rule of thumb which says never run a component newer than the API server. So essentially your API server should be running a version higher, not lower than any other components. And I will let you read rest of it in this documentation. But again, when you are dealing with production implementations, you will typically upgrade all of these at once. But I want you to understand one caveat. kubectl client is often in your laptop or in your jump host. So you must ensure that it is in line with the version of the API server. Now, why I am mentioning this separately is because you could be dealing with multiple clusters in production implementations, and some clusters could be running a different versions and some could be running a different version. In that scenario, ensure you kind of have a balance between which version of kubectl you wish to use. And if you have such scenario, then what you can do is you can have multiple kubectl binaries in your jump host or in your laptop and then decide different aliases for them and use them with the appropriate cluster. So keep this thing in mind, and this is an important part. For admin laptop CI images, staying on n or n+1 is practical. On nodes, match the node's kubelet to avoid drift. So plus minus one minor of the API server. And in case you are not able to adhere to this, you can use multiple kubectl binaries. Now let's see why upgrade matters. First is security and compliance. We all know this. Second is features and APIs. For example, if I talk about 1.33, there is an important feature which can perform vertical scaling of pods without a restart. Hence, you do these upgrades to leverage those features and APIs. Lastly, ecosystem compatibility. Maybe the CNI or CSI that you are using does not work with the Kubernetes version you are currently running. In such scenarios as well, you will have to upgrade your Kubernetes version. Now, let's see a high level upgrade flow that you will see in production implementation. But I want you to understand that each environment is different. Each environment is subjective. The requirements are subjective. So your environment may need some more steps or few less steps. It all depends on your implementation. So here I am giving you a generic flow. First is pre-checks. verify control plane and HCD health, ensure capacity headroom. For example, if you have 3 worker nodes and 3 worker nodes are already at 80% utilization, then you will have to have extra headroom capacity so that you can upgrade your worker nodes. So ensure that your worker nodes are at a healthy utilization, and if taking one node out will disrupt your workloads, then always add a node before performing these upgrades. One node, two node, these things are subjective depending on what sort of load your cluster is withstanding. Second is control plane, one node at a time. Now there are on-premises implementation self-managed clusters which are using multiple nodes for control plane. This is called HA. In that scenario, you will have a different upgrade path. For example, when you have multiple control plane nodes, then what you do is in the first control plane node, you run this command, you apply the upgrade. In the remaining of them, you just do kubeadm upgrade node. Now, these things are just commands right now. As we move on to the demo section, all these things will make sense. Workers, one node at a time. We will be using cordoning plus draining. We will be discussing pod disruption budgets. What are these? And then finally ensure that the components that you are using, because your application is not just using Kubernetes, there are monitoring tools, there are security tools, backup tools, CNIs, CRIs, CSIs. You must ensure that while you do this upgrade, all of those things are compatible with your existing tooling. In case it is not, then after the upgrade those things will not work. So you must ensure that all the components are working before you step into upgrading your production grade cluster. So essentially you will be doing all these testing in your development environment first, then you will be doing these things in your staging environment or your pre-pod environment, but ensure all these things are done before you make any changes in the production environment. Post validation check node server client versions, component health and logs, run synthetic traffic probes, and revert any temporary scale out. So this is just validation. Once everything is upgraded, you test that everything is working as expected. Most of the production workloads will have a script that will run a health check to ensure everything is working fine. At infrastructure level, then your application teams will also perform their validation and give you a go ahead. Okay, DevOps team, my applications are working fine. You can make this upgrade as a successful one and then do a small party. Upgrade strategies is next. Now, all at once, this is acceptable for dev and test clusters which do not have any service level objectives. Then you have a rolling. This is the one that we will be doing in this demo, that is one node at a time. Blue green, I will touch this briefly. What happens is, let's say you have 5 worker nodes associated with your control plane. You upgrade your control plane and then you add new worker nodes to your control plane. Now, how many nodes you add? You add the same quantity of worker nodes that were associated with your cluster before. And these green nodes that you have added, they are running with the version that you desire. And once this green nodes are added, only then you remove the blue nodes. Now, this is a costly deployment style because you have to have the similar infrastructure ready. Hence, you will see this in extremely critical workloads, but in general use cases for the Kubernetes cluster and for worker nodes, you might not see this, but the applications that are running inside your cluster, they could follow blue-green deployment model, and there are ways via which you can do this in Kubernetes cluster, and we will see this when we discuss different deployment strategies. But from a cluster perspective, you will not see many production environments using blue green, but again critical environments could be using these, because there are always exceptions, there are always use cases which warrants something special, but again this will have higher costs. Now with all this understanding, let's move to the demo section. And what we will be doing, we will be upgrading Kubernetes 1.32.8 to 1.33.4. Now the scope and assumptions, the assumption is only one right now, that you have a working Kubernetes cluster which is one minor version below what I am using. I will be upgrading to 1.33.4. If you want to follow along, then you should be using 1.32. This patch release could be any, but if you have followed my day 54th lecture, then you are good to go as is. Now first is prerequisites. As I told you, we must first verify that whatever we are doing is compatible with the external tooling or the tooling that we are using to support our application. So here I want to check whether what I have in my cluster is compatible with the version I am upgrading to. For example, I am using Calico 3.30, so I must ensure that my implementation will be compatible with this version. And if you see this screen, version 3.30 is compatible with all these Kubernetes versions, and we are upgrading to version 1.33. And then I also want to see the CRI compatibility. Now if I go to my terminal, what I can do is I can run containerd -- version. This will show me the version of containerd I am using. Containerd is the container runtime we are using. It is 1.7.27. So if I go to the documentation of containerd, then I will see that this containerd version that I am using is compatible with version 1.33. And if I see here, you see 1.7.24, anything above 24 is compatible, and we are using 0.27, which is of course compatible. Next I want to see is capacity headroom. So we are running a few pods, but the capacity that we have right now, 2 worker nodes, are sufficient. PDBs and probes pod disruption budgets, we will see them as we progress, and there is a use case for that. This is a backups step. Now before you upgrade your cluster, you should always take a backup of everything that is running. So all the manifests should be backed up. Ensure you do not have single pods running, because single pods are not managed by any deployments. If they are killed, they are killed, they are gone, they won't be restarted. Ensure you do not have any orphan pods which are not part of any deployment. Then you must ensure that you take backup of your HCD. It is of paramount importance. Now the documentation clearly says that Kubernetes upgrades, they do not touch your data plane, as in they do not touch your workloads, your application manifests. But again, they also recommend that you take backup of everything. So hence I recommend you take backup of everything that is running in your cluster. Then HA specifics. Now if your control plane is highly available, then you will have to follow a different method, as in there is a slight difference between the steps, and I have jotted those points in this documentation itself, so that you do not have to go anywhere else in case you have a highly available control plane, as in you are running 2 or more nodes to run your control plane. And here is an important point. Now when we want to check the health of the cluster, and health of the cluster, you know, API server is the entry point to any Kubernetes cluster, and /Redis is the endpoint that you monitor to ensure that your cluster is healthy. So the API fronting LB health checks /redis must be monitored when you are upgrading your highly available control plane nodes. Now, in the API lecture of this course, we discussed about this at stretch. If you want to know more about it, then I will recommend you to go and watch that lecture. So that's about the prerequisites. And again, these prerequisites could be different for you. You will of course have to inform your application teams that you are doing these upgrades and all these things. So I will leave it at that. Finally, let's do the interesting part, that is, let's upgrade the control plane nodes. So what I have is I have two tabs. The first tab has the control plane, the second tab has worker 1 and worker 2. So first tab is where I will be running the commands that are specific to control plane. So let's go here and see what we want to do. So if I copy this command, let me first copy and then I'll tell you what we are going to do. I'll paste it here and I'll press enter. So what you see here is right now the repository that apt is using for kubectl, kubeadm and all the packages related to our Kubernetes implementations, they are coming from version 1.32. Now what we want to inform apt is a package manager in Ubuntu. What we want to inform apt is now I am ready for an upgrade, hence anything that I do related to apt should be working on version 1.32. So if I am trying to upgrade kubeadm or kubectl, you should not be referring to this repository, because this repository only has packages associated with version 1.32. I want you to look at the repository that has the packages for version 1.32. Hence what I will do is I will vi this file. I'll hit control. I'll first remove this. I'll hit the up arrow, control A to move at the front of this. And then what I will write here is sudo vim and this file. I'll press enter and I will go in the insert mode. And then what I want to now do is 1.32. I want to change this to 1.33. Now in case you are on 1.31 and you see 1.31 here, you should not be writing 1.33 directly. You should first be writing 1.32. Once you perform that upgrade cycle to 1.32, only then you move to 1.33. So for now I'll just do 1.33. I'll hit escape shift ZZ to save this file. This file is now saved, and then I will go to my browser. And this step we have already performed, and let's move to the next one and determine the exact target version is what we want to do in step 2. So what we are doing is sudo apt get update. This will refresh the index in accordance with the newly configured repository. Let's copy this first and then I will paste it in the terminal. I'll press enter. This will update the index. Then I will do sudo apt cache medicine kubeadm. This will show us all kubeadm versions available at our disposal. So this is interesting. So let's go here. I'll run this. Now I want you to see one thing. It is saying that with this repository, the repository that we just added for 1.33, you are free to go to any of these versions. Now, like I told you, in production environments, if you are going to the latest minor release, you might not want to go to the latest patch release, so you will be changing that accordingly. But in our demo, we will be choosing this. So this command will give you a very good summary of what all versions are available in this repository. Now, not what all versions, what all patch releases are available in this repository. So this repository has everything 1.33 from 0, patch release 0 to patch release 4, which one is the latest. So we'll go back to the repository again. Then I will do this command and I'll tell you what we are doing. I'll paste this here. Now we are saying unhold kubeadm. So what you will see in production implementations is whenever you are dealing with any of the Kubernetes related binaries. So for example, there is kubeadm, then there is kubectl, then there is kubelet. You do not want anyone to come into your control plane node and upgrade these. So what I am saying is, if anyone is running apt specific commands, if anyone runs a command that upgrade every package, then you do not specifically upgrade kubeadm. So that is what a hold will do, and it is an important part. So whenever we are done with our installation, everything is done, you put a hold on these things. So what a hold will do is it will pin the version that you have right now, and if anyone runs these apt upgrade commands, these packages will not be upgraded, and that is what we want. We only want these packages to be upgraded when we are doing the cluster upgrade. So we want things to be predictable, hence we put a hold. So right now, since we want to upgrade the kubeadm version to the latest, which is 1.33.4, hence I am unholding it right now. So cancelled hold on kubeadm. Now let's run the next command. So in this command, what I am saying is apt get update, apt get install. I want you to install this version of kubeadm. And how do I know I want this version? Because I ran this command. That is why I know I want this version. So always understand what are the repercussions of the command that you are running. Do not follow the steps blindly. If you have any questions, any doubts, search the web. If the web is not helping, ask me in the comment section. Maybe I'll have an answer for you. Now let's go back. Now I have upgraded my kubeadm, so I will put the hold back first and I'll paste it here. So the hold is again there. So now I can run kubeadm version. So this will tell me the version of kubeadm that I am using right now. I'll have to spell it right, kubeadm version, and the version of kubeadm is 1.33.4 like we expect. Now let's go back to our repository and see what the next step is. Plan the upgrade. Understand, this is like Terraform plan. This will not do anything. This will just tell you what should you expect. So I'll copy this, I will paste it here, and this will tell me what is that will happen if I go ahead with this upgrade. Now, important thing. Components that must be upgraded manually after you have upgraded the control plane with this command. So we'll be running this command next. So what it is telling you is kubelet must be manually upgraded, and also kubectl client will have to be manually upgraded. The things it will be upgrading, the kubeadm utility will be upgrading, are these things. Now I want you to observe something. Whatever kubeadm is not upgrading for us, they run as services or they run as binaries. If I talk about kubelet, it runs as a service, and similarly, kubectl client is also a binary that you use to connect to your cluster. Hence, kubeadm is not touching those things. So kubeadm is only upgrading the things that run as pods. So if you see all of these components, they run as pod, and kubeadm is only upgrading those components. Now I want you to contrast this with your application upgrades. So if your application is right now running version 1 and you want to upgrade your application to version 2, what you do is you create a new Docker file, and from that Docker file you create a container image, and that container image is version 2, and then you deploy that image into Kubernetes, and your application is now running version 2. as simple as that. That is what you do to upgrade your application. Now come back to Kubernetes. What you are now doing is you are upgrading your control plane components. Then kubeadm at a very high level, what it is doing, it is just upgrading the images that are there for these components. So for example, API server has a manifest file. In that manifest file, if I change the image to the latest one, then I am running the latest version of Kube API server. Similarly, for all other components, and I want you to know that 4 of these, API server, controller manager, scheduler, and etcd, they are running as static pods. So if I cd into etc kubernetes and then I hit ls, we know that the static pod manifests are saved in this manifest directory. So what I will now do is I'll sudo cat manifests, and then here I want the manifest for API server. Let me first hit ls here. Let's do ls, and I'm not allowed to do that. Let me add sudo here, and here is the manifest for our API server. So let me do one thing. Let me cat on this manifest. I'll write manifest here, then I'll add this and I'll hit enter. Oh, I'm not supposed to open it. Let me add sudo here. And here is the image that this manifest is using. So understand that my Kubernetes API server is right now using version 1.32.8, which is the version that we are running right now. And when we upgrade our cluster using kubeadm, essentially kubeadm will replace this with the new image tag, and similarly it will add few more parameters here and there which are associated with this version, and it will do the same steps for other components. So I want you to create a mental map with me when you are working in such scenarios. So let me clear my screen. I will again go back to my home directory, and then I will run the same command again so that we can see a few more things. So these are the target versions where all these things will be upgraded to. So let's go back to our browser. I will copy the next command that I want to use. Plan we have already done. Then I will go to step 5. Step 5, we will be applying this. I'll copy this and then I can paste it here. I'll press enter, and this has started doing its magic. So I will say yes, I want to upgrade. So here it is saying this is your current cluster version, this is your kubeadm version. You have chosen to upgrade the cluster version to 1.33.4. I'll say yes, we want that, and this will do its magic. Now I want you to again understand what it is doing. It will change all the versions in the static pod manifest files to the version that we want to use, that is 1.33.4. So let's go back to our GitHub repository and see what we want to do next. Now once it has done its job, we will be verifying using kubectl version and kubectl get node. So let's go back here and wait for it to complete. And you can see here what it is doing. It is backing up our previous manifest so that if we choose to do a rollback, we can refer to these. Now it is doing the same for the Kube API server, what it did for our etcd's YAML. See, now you would be wondering about why this path, but again, if you have any confusions about this, you go to the static pod lecture. I will link that in the description as well. So the reason why these typical complex topics like cluster creation or cluster upgrades are placed at the very last of this course is because so that you have all the understanding to understand the concepts that are required to fully grasp what we are doing. So in case you do not understand static pods, then you would be wondering what this path is. So for now, just understand that your control plane components, they run as pod whenever you set up your cluster using kubeadm, and the manifests for the static pods can be found in the path that you see on your screen right now. And you see it has now moved to upgrading the kube controller manager. So the sequence is, it first did for HCD, then kube API server, then controller manager, and finally it is dealing with the kube scheduler. Okay, the control plane node of your cluster was upgraded to 1.33.4. Now let's see what we want to run next. We want to run kubectl version. This will tell us the client version of kubectl and the server version. So the client version is still 1.32.8, which is we expect, and then the server version is 1.33.4. So this is how you do an upgrade for your control plane. Now let's run kubectl get nodes. I want you to clearly understand the version that you see here is for the kubelet, and the kubeadm utility explicitly told us that I will not be upgrading kubelet. You will have to do that on your own. So let's see what we want to do next. So in step 7, upgrade node local bits on the control plane node. So first I will unhold both kubelet and kubectl, then I will upgrade them to the required version. And why I can do that? Because I added a repository that has all the packages 1.33. Then finally, once the installation is done, I will perform a reload, and then I will again put a hold onto these utilities. So I'll copy all these commands from here and I will paste this onto my control plane node. So you see, canceled the hold, and then it is performing the upgrade. So once the upgrade is done, I will again put the hold. kubeadm was already set on hold. Now I will run kubectl version again, and you will see that our kubectl client is also upgraded to 1.33.8. Let's allow it some time. It is not displaying the server version right now. Client version is 1.33.4, which we expect, but the server version is not displayed because kubectl client cannot connect to our API server. So let's quickly run kubectl get pods to see what's wrong. So kubectl get pods is running. As you can see, I already have 10 pods. And now let's run kubectl version. This should succeed now. There was a temporary glitch, and now you see both our client and server are running version 1.33.4. That is what we wanted. And finally, let's also check kubectl get nodes and verify the version of kubelet as well. And you can see the kubelet on our control plane node is on 1.33.4. That is what we wanted. Now we are done with our control plane node. So let's go to our worker node and do our magic. So let's come here. And here I have given some pointers about HA clusters. I will let you read those, but the crux is you perform the upgrade on your first node, and after that what you do is kubeadm upgrade node. This is the command that you use. So just give it a read. Now worker node upgrades one at a time. Now first command is kubectl cordon worker 1. And then second command is kubectl drain worker 1, ignore daemon sets, delete empty dir data. What does cordoning mean? So firstly, cordon is when I cordon a node, the scheduler will take it out of the scheduling algorithm. It will not schedule any new pods onto that node, but the existing pods that are running on the Cordon node will continue to work fine. So if I go to my terminal again, I will run kubectl get pods and I will add -o wide here so that I also know on which node these pods are running. You see these pods are distributed amongst worker 1 and worker 2. So now let's do one thing. I will copy this command and I will just paste this command here. Okay, and once I do that and I run kubectl get nodes, you will see that this node is ready, but scheduling is disabled. Why scheduling is disabled? Because I just cordoned this node. So if I now run kubectl get pods -o wide, I will see that my pods that were running on worker node 1 are still working. Okay, so this command just disabled scheduling of new pods onto this node. So let's go back and see what will drain do. Now the drain is something that respects pod disruption budgets. We will see what these are. Now we know that our worker nodes, they also run daemon sets. So if I go here and I run kubectl get pods -n, I'll write -a because I want to see all of them, and then I will write here -o wide and press enter. If you see, worker 1 is not only running our workloads, worker 1 is also running, if I scroll up, it is also running the Calico node, it is also running the CSI node driver. So these are daemon sets. And if I run kubectl get ds -a, then you will see that all our nodes will be running these kube proxy pods and Calico node and also CSI node driver. So all these pods are also running, and we explained what are these in our previous lecture in day 54, so you can watch that. But for now, I want you to understand that our worker nodes are not just running our web pod, they are also running daemon sets. So here what I'm saying is, when you drain this worker, what does draining mean? Draining implies that this node, whatever workloads are running here, they will be kicked out immediately. And we are saying you also kick out the daemon set, which is why we have added -- ignore. And same we are saying for mtdir data. So what I'll now do is I will copy this and then I will paste it here. I press enter. And just like that, it evicted all my pods. Is it fair? As a DevOps engineer, you would be saying, yeah, Varun, it is fair. That is what we wanted. But is it fair from application's perspective? Maybe the application that was running here wanted 10 pods to be running at all times. And maybe the remaining worker, that is worker 2, will not be able to withstand those pods, may not be able to run those pods of XYZ reasons. Maybe the load on worker 2 is so much that it cannot run more pods. But my application, which was running here, wanted 10 pods at all times. And this command, draining the node, it just kicked out everything that was running in that node. So is there a way to prohibit it? Yes, there is. And that is where pod disruption budgets come into play. So let's briefly understand that. I do not have a demo for you right now on pod disruption budgets. We'll have that later. But for now, I want you to understand there is a way via which you can ensure that when I am talking about this application, I want this application to always have these many pods. So if your application requires 10 pods at all cost, then you can achieve that using pod disruption budget. So what will happen is, if you try to evacuate a node using drain command, then if that application has PDB set, pod disruption budget set, then Kubernetes will not allow you to drain that node. So let's understand this in a diagram. So I'll go to my diagram section, and here is what we just did. So we were on worker 1. As soon as we ran our drain command, all the pods that were running in worker node 1 were evicted. Now I want you to imagine there are two deployments. One is red deploy and second is green deploy. Now green deploy is not that important for me, but red deploy is extremely critical for me. Now I want that my red deploy should always have 3 pods running. But as soon as Varun ran this command on worker 1, all these 3 pods along with the daemon sets that were running were kicked out immediately. And when that happened, I only had 2 pods in my red deployment, and that is not something I want. I want 3 pods of red deployment should always be running. So what I did is I came here. What you see here is, here on the left is a manifest for my red deploy, which says I want 4 replicas. Like you see, we have 4 replicas for red deploy, which is fine. Then what I also did is I created a pod disruption budget, and in the pod disruption budget, what I said was the minimum available for the pods that have app is equal to red deploy label, and here the pods have app is equal to red deploy label. I want the minimum available pods for any pods that match this label should be 3, which implies if I run this command here, then these pods should not be kicked immediately, because what I want is I want 3 red pods to be always running. And if all these are kicked simultaneously, then that condition will not be met. So once I apply both of these manifests, once I specially apply this pod disruption budget, then it is responsibility of Kubernetes to ensure that this red deploy always has 3 pods running. So let's see what will happen. I have 2 scenarios for you. Scenario 1, worker 2 has enough capacity. When Varun runs this drain command, what will happen is only 1 red pod will be evicted, because 3 must always be running. And once the evicted pod is recreated on worker node 2 or any other node and is in ready state, only then this pod will be terminated. So Kubernetes will ensure that you always have 3 pods for this red deploy. Then second scenario is worker 2 doesn't have capacity. Now let's say first pod was terminated, and it was terminated gracefully, and it will do that because you only want 3 pods to be running at all times. So 1 pod will be terminated. But when it comes to the second pod, and if there is no capacity in your cluster, let's say you only have 2 worker nodes and worker 2 is already full, in that scenario this pod will not be evicted. Hence worker node 1 will not be drained, and you as an administrator will not be able to perform that upgrade in worker node 1 until and unless you ensure that the red deploy has enough pods, has 3 pods running. So keep this in mind. As administrators, you will often be configuring pod disruption budgets to ensure the critical workloads that require a certain amount of pods running at all times are not disturbed because DevOps team decided to upgrade the Kubernetes cluster. So keep this thing in mind. Now I want to highlight one more thing. If someone powers off this worker 1, then pod disruption budgets will not be adhered. So these are only applicable, or these will only help you when there are planned outages, planned downtime, not when someone deliberately powers something off or deletes something. I want you to understand that we discussed pod priority and so many things in our previous lectures. Pod priority was helping us during the scheduling time, but once the pod is running, these priorities are not considered. Hence, pod disruption budget are must to be configured. Now I brought this topic here because when you are facing interview questions or working with real-time production scenarios, you will be asked these things. How did you ensure during your cluster upgrades that your application continued to work fine? And this is one point that you can always mention. First is I will do step-by-step upgrade of one worker node at a time. And then second one is I will ensure that pod disruption budgets are in place for critical workloads so that my application teams do not raise complaints for our DevOps teams. So let's go back to the GitHub repository and run the commands that we want to run. So we have drained our worker one now. Now we want to upgrade it. So I will simply copy this, and we have already seen these commands. So first I will add 1.33 as our repository. So I'll copy this. I will go to my terminal. I will go in this tab. Now I want in worker one, I will increase this size a little. I will paste this here. I will hit enter. I will go into insert mode. In place of 1.32, I will add 1.33. So I will add 1.33 here. I will hit escape, shift ZZ to save this file. I'll go here. I will now copy all of these things. I'll copy this. I'll paste it here. I'll press enter. Then I will see what I want to do next. As simple as that. Your worker node is upgraded. So what we did is we first put an unhold on kubeadm, kubelet, and kubectl. Steps are common. We did this also in our control plane node. And then here what we are saying is install this, and then once the installation is done, we are again putting a hold. Holding things are important, and I want you to know that the Cordon command, the drain command, we ran from the control plane node because it is the control plane where we have our kubeconfig file. In worker one, I only ran these commands. Now I will again run these commands from our admin shell, and for us our admin shell is our control plane node. So I'll go here, paste these commands here, I'll press enter, and worker one is uncordoned. So what I have now here is worker one is now running version 1.33.4. If I now run kubectl get nodes, similar to this, you can see the succinct output here. I can also run kubectl get pods -o wide, and you will see there are no pods running in worker one right now because these pods are already scheduled here. Now people who are here from VMware background, I want you to understand you could vMotion a virtual machine from one host to another, but pods cannot be vMotioned. You cannot move pods from one node to another. You kill the pod and then it is restarted onto the same node or onto any other node depending on the scheduler's algorithm. There is no live migration of pods from one node to another in Kubernetes. So keep that in mind. Now only workloads will be scheduled in worker one once I Cordon worker 2 for our next demo. So what I will now do is I will again go here. I will copy this command and then I will come here. I will paste it here and then I will write worker 2 here. I'll press enter, and then what I can also do is if I directly run this command, then it will automatically cordon. But I wanted to show you the difference between cordon and drain. Hence I wrote both of these. So I'll copy this as well and I'll paste it here. And here instead of worker 1, I will write worker 2. So worker 2 is now drained. So now our pods should be running in worker 1, which is already upgraded. So I will run kubectl get pods to ensure that our worker 1 is behaving as we expect. I will hit enter. I will also have to add -o wide, and you see my pods are working just fine in worker node 1. Now understand, in production implementations you will only uncordoning a node once everything is working as expected, and once you uncordon you will try to schedule new pods onto it and see whether they are behaving all right or not. Only then you would want the production workloads to be running onto your upgraded worker nodes. So I will go back here and then I will run this in worker node 2. I'll copy this. I will go here. I will go to this tab. I will go to worker 2 now. Here I will paste this. I'll hit enter. I will go into insert mode. And then what I will do is I will quickly make this 1.33. And once this is done, I will come here. I will copy all these commands and I will paste them here. I'll press enter. And we already know what these commands are doing. And once I am done here, I will quickly see once it finishes, I will uncordon it. I'll go to my first tab now. I will run kubectl uncordon worker 2. I'll press enter. And now I will run kubectl get pods and I will write a -o void here. There will be no pods in this node, but what I want to show you is kubectl get nodes, and here you see all my worker nodes are running 1.33.4 of kubelet, and hence everything is working smoothly right now. So what I can now do is I can write kubectl scale deployment, and the deployment I want to scale is named web, and I want to scale this to 20 replicas. And if I do this, and if I run kubectl get pods -o void, I see the pods are also being scheduled onto worker node 2. Now, before I perform the final validation, what I want to do is I want to restart this node. So I will write sudo init 6, and here as well I will write sudo init 6, and then I will do the same for my control plane node as well. My connection is broken, hold on. Yeah, and I'll check this one as well. Now I'll go to this tab. Here as well I will do sudo init 6. So I should have rebooted control plane once I was done with the activity. It is always good once you are doing an upgrade, you restart your nodes so that everything stabilizes. Worker nodes should have already come up. So worker 1 and worker 2 are already up. So I am in the control plane node. Let me hit up arrow and log in again. I'll clear my screen. I will run kubectl get pods, and here all our pods are in running state. They only have had one restart, which is expected. The restart happened because we rebooted our node. That is fine. Now I will run kubectl get svc, which shows that I already have a service which is listening on 304.3.8. So I will go to my browser. I will go to this console here, AWS console. I will copy the IP address of this worker. I will write http:// I will paste this, and the node port was 304.3.8, 304.3.8. I'll press enter, and voila, we see welcome to Nginx. And let's do the same with worker node 2. I'll copy this. I will write http:// I'll paste this here, and it is 304.3.8, 304.3.8. I'll change that https to http, and then I'll press enter. And here also welcome to Nginx. So everything works as we expected. Now again, if things are not working for you, allow it some time to stabilize. So first is you reboot your servers after the upgrade is done, then you allow it some time to stabilize. I had stopped the recording because we were able to access the Nginx service just fine over our node port. But later, after I was just doing a quick sanity check again, I realized that the Calico node pods, these are in running state, but their status is not ready. So what I did was I troubleshooted this further, because Calico node is your CNI pod and it runs as a daemon set, Calico node, and it is critical for the workings of the CNI. Hence we want that this pod should be in ready state. Right now it is not, which is a concern for us. Even though our web pods were accessible, they were in running state and we were able to access them over the web, but this problem must be fixed. So what I have done is I recreated a cluster, upgraded that again to replicate this scenario so that I can troubleshoot this along with you. So I have already done initial troubleshooting, what the cause is and how to fix it. So let's walk through on what was my approach to fix this problem. Firstly, I saw it is not in ready state. The first thing I did was I did a kubectl describe pods -n Calico system. Then here I copied this pod name. I can do that for any pod, and then I pasted it here. And when I pressed enter, I saw that there is an error that says bird is not ready, error querying bird. Now this error pertains to BGP, but then I thought to myself that BGP is not something that we are using. As I discussed in day 54 of this lecture, we are using VXLAN that does not use BGP, and accordingly we opened our ports. So for now this error is there because TCP port 179 is not allowed, which is used by BGP. But in our scenario we do not need BGP, so there must be some way via which I can disable BGP, and this is something that is also recommended by Tigera, by Calico. They have not explicitly done it here, I'm not sure why, but if I go to their documentation, they say here when you are using Kubernetes VXLAN, ensure that BGP is disabled. And you read these two lines as well. If you installed Calico using the manifest, that is not using operator, then BGP is already disabled. But what we did was we used operator, which is the recommended approach to install Calico. Hence for us BGP was automatically enabled, so we do not want that. First let's do one thing, let's disable BGP. Now I will go to my GitHub notes. I have added another section here which is called Calico post upgrade troubleshooting. So I'll click here. I will also zoom in a little, and here is the way which will tell you whether BGP is on or not. So I'll copy this and I'll go to my terminal and I will paste this here. And when I do that, it says enabled. Hence BGP is enabled in our cluster. So let's do one thing. I will disable it using this patch. So I recommend you also run this. I'll copy this and I will paste this here. And another thing I want to highlight here is I will add this note in day 54 lecture as well, so that the folks who are watching that lecture can do this thing right away. Because even if you have a newly created cluster and followed the instructions I gave in day 54, then day 54 cluster would also face this problem, because we used the settings that are available by default in Calico's documentation, but we do not need BGP. Hence we should create our cluster using these settings itself. Now if you have already done this in day 54, because I would have added this as steps in day 54 as well, then you do not have to do it after the upgrade. Your cluster would be working fine. But for folks who have not done this, I am mentioning this here itself. So I will copy this, and it says that it is patched. Now once the patch is done, I want to do a rolling restart of Calico node daemon set. So I'll paste it here and then I will do a rolling restart. I think this screen is in hung state. I'll press Ctrl C and let me run kubectl get pods -a. Now if I run this again, you see that 2 pods are working fine, and still there is one pod that is not working. It is not in ready status. I will copy the name of the problematic pod. Then what I will do is I'll do kubectl logs -n Calico system, and then I will enter this here and I will paste it, and this will tell me what is going on with this. It's saying reporting non-ready. So if I go up, and this is pertaining to Felix, it is saying Felix is not able to start up because port 5473 is not allowed. Now, but Varun, we were not using 5473. You never mentioned in day 54. What happens is there is a component called Taifa. You typically will not require that component because that is only needed when you are dealing with extremely large clusters, because Taifa is something that acts as a caching solution. It acts as a fan out solution. But in our installation, Taifa came in by default. If it came in by default, we should make it functional, or we should just remove it altogether. So what I opted for was, I opted to keep Taifa so that anyone who is dealing with a production implementation that uses Taifa can also benefit from this. So Taifa requires port 5473 between all your nodes. So between your worker nodes and between your control plane nodes. So if I now run a describe on this pod, which is not in ready state, I can write kubectl describe pods, and I press enter. You see that it is saying that readiness probe failed, Calico node is not ready, Felix is not ready, readiness probe reporting 503 error. So let's do one thing. Let's go to our browser and I will go to the security groups section and I will go to the control plane security group. I will edit inbound rules and I want to add a rule for TCP port 5473 and I want to allow this from data plane security group. I will save this rule and then I will go to the data plane security group, and here also I will add two rules here, one for inter worker communication, one for the communication from the control plane. So I will add 5473 here, and the source will be first from itself because two workers could be communicating with each other, and then I will add one more rule and this one will be from control plane security group. I will save this, and as soon as I do this, that communication will start to work fine. So let's go to the terminal and I will again see kubectl get pods -a, and see it is now in initialization stage. There are init containers for this which are now running. So let's again run this command and you see it is still not in ready state. So let's allow it some more time. It's still not in running state. I will run this again, and now the status is all good. Now all our Calico node pods are working fine. I want you to know that Calico node runs as a daemon set, and this is actually the pod that is doing all the legwork in your nodes. So this pod must always be in healthy state. And lastly, I also want to quickly verify that our page is still accessible. Since this is a new cluster, you know, my node port has changed and my service is accessible on both of these nodes just fine. And I think that is all I wanted to cover in this lecture. That brings us to the end of this Kubernetes cluster build and upgrade masterclass. In this session, we built a multi-node Kubernetes cluster step by step using kubeadm, understood Kubernetes versioning, release cadence, and upgrade sequencing, performed a full rolling upgrade of the control plane and worker nodes, verified cluster health, and handled post upgrade checks, including Calico. I strongly recommend practicing these steps in your own lab. Cluster upgrades are not just about commands, they are about confidence, sequencing, and knowing what to check when something goes wrong. If you have feedback, suggestions, or topics you would like me to cover next, please leave a comment. If this video helped you, even a short note about what worked well or what could be improved goes a long way. And if you think this session can help someone else, sharing it with a colleague really helps. If you would like to follow along, you are welcome to subscribe. I regularly publish hands on content on Kubernetes, Jenkins, Argo CD, CI/CD pipelines,
and production grade DevOps practices. I will see you in the next session. Until then, thank you very much.